Let's go on a little road trip. We'll start at point A and we'll drive to point B at an average speed of 60 miles per hour. We'll then return to point A, going the same distance on the same road we took to get to point B, but this time a little slower, averaging 40 miles per hour. Given these two speeds, the question we want to ask is, what's our round-trip average speed? Pause the video and see if you can answer this question correctly. It looks like Rise to the Equation is giving you a softball question. We know the average of two numbers is just their sum divided by 2. And in our case, the average of the two speeds is just 60 miles per hour plus 40 miles per hour divided by 2. That's 100 divided by 2, which of course is 50 miles per hour, right? No. The correct answer is not 50. Let's see why. Let's use an actual distance for our problem. How about 120 miles, since that's going to keep our calculations nice and clean? Now we'll figure out how long it takes to go from point A to point B. We'll call that time t1, which is equal to the distance divided by the rate, or speed, and we'll call that r1. Plugging in our values, we get 120 over 60, which is 2 hours. Now let's get the time to go from point B back to point A. We'll call that t2, and using d over r2, we get 120 over 40, which is 3 hours. It makes sense that the slower speed requires more time. Our round-trip average speed will be the total distance divided by the total time, which is 240 over 5. And that gets us 48 miles per hour, not 50. The reason is simple. 50 miles per hour would be the correct answer if the car spent an equal amount of time going at 60 miles per hour and at 40 miles per hour. However, we know that more time was taken going at the slower speed, which in turn brings the average below 50. Let's take this one step further and find an equation that we can use to get the true average speed for any two speeds, not just 60 and 40. Just like before, t1 will be the time it takes to go a distance d at a rate or speed of r1, and t2 will be the time it takes to go the same distance d at a rate of r2. The average of the two speeds, or the round-trip average speed, will be the total distance over the total time. That becomes 2d over t1 plus t2, which in turn becomes the following. Let's now add the fractions in the denominator. That leads us to this expression. We'll now multiply top and bottom by r1 times r2. And now we can cancel out a pair of the r1, r2s. Our expression simplifies to this. Let's factor out a d from the denominator. And notice that the d's will cancel, and that leaves us with our desired formula. In other words, to get the true average speed, just double the product of the two speeds and divide by their sum. Let's make sure this formula works for our specific problem. We'll plug 60 and 40 in for r1 and r2, which gets us 4,800 over 100, which of course is 48. I hope you enjoyed this video. If you did, please give it a like and consider subscribing. Also, I'd love to get your feedback in the comments. Thanks for watching, and see you soon.